Hi there, welcome to this video where we will try and understand what is a web service. Let's consider a simple definition of a web service. A service which is delivered over the web. Is that a complete definition? Think about it. So if I deliver a service over the internet, over HTTP, does it really become a web service? You might be using a lot of web applications, right? Facebook, Twitter, your shopping applications, wide variety of applications. Are all of them web services? Let's consider to-do application that I have built. This application helps you to log in, log out, and try and manage your to-dos. You can add new to-dos, delete existing ones, and also update the to-do information. This is a simple web application which is built using Java and Spring MVC frameworks. Is this a web service? Let's consider a situation. A friend of mine, he's building a social application. Let's call it something like Facebook, right? So he wants to add the features to manage to-dos into his application. He wants to reuse some of the functionality from our to-do application which we have built. Will he be able to use the application as it is? The current application as we have built it delivers HTML output. HTML is a format which is designed for rendering data on the screen, on the browser. HTML supports, like, I want my menus here, I would want this data, I would want these buttons on my screen. I can use HTML to design that kind of stuff. HTML is not really a format which is designed for application to application interaction. My friend does not want to give up so easily. He says, okay, the output that you are delivering in, it's not consumable by my application. So what are the other options that are present? He comes to me and tells me, hey, haven't you really designed your application very well? Your application is really having well-defined layers. You have a web layer, you have a business layer, and a data layer. Can I reuse this stuff from your business layer? The output from your web layer is HTML. I cannot use it. But can I reuse your business logic? He comes to me and says, okay, can I create a jar with your business logic and reuse that stuff? That's a good option, right? Think about it. He wants to create a jar out of the business logic. Can he use it as it is? What does the data layer need? The data layer really needs a database, right? So it needs a database to talk to. So what my friend needs to do now is to install a database, and also there would be other dependencies. So he would need to make sure that all other dependencies are satisfied. Think about when there's a change in the business logic. So let's say I am upgrading my to-do application to have some new business logic. Will he automatically get it? Nope. I need to actually create a jar and provide him a new version of the jar so that he can get the new version of the business logic. We cannot consume the output from the web layer, which is HTML. And there are a lot of problems associated with creating a jar and trying to reuse it that way. If the to-do application is able to provide output in a format that other applications are able to understand, then will it solve the problem? That's where the concept of a web service comes into picture. What we are looking at right now is the W3c definition of a web service. It says it's a software system designed to support interoperable machine-to-machine interaction over a network. The three keywords are interoperable, machine-to-machine interaction over a network. The first thing is web services are designed for application-to-application interaction. My to-do application is not a web service because it's not designed for application-to-application interaction right now. It's only designed for a human interaction. If another application wants to talk to it, the to-do application is not ready yet. Should be interoperable. Any other kind of application should be able to talk to my application. It can be application A which is installed on .NET, application B which is installed on Java, and application C may have been built using PHP. Irrespective of their technologies, they should be able to talk to my to-do service. That's when my to-do application will become a web service. And the last one is it should allow communication over a network. We were talking about this jar option, right? So when I create a jar and give it to my friend, then the jar is installed locally. Communication would happen within the boundaries of the system. The communication will not happen over the network. In that scenario, this is not really a web service. For an application to be a web service, it should allow communication over a network. Other applications should be able to talk to it. The applications could have been deployed anywhere. They might have been deployed on the same system, on a different system, or somewhere on the internet. They should be allowed to talk to my application. Only then my application will be a web service. What we have done in this video is try to understand the most important things that a web service should support. We learned that a web service should support application-to-application interaction. It should be interoperable and it should allow communication over the network. In the next video, we will look at how to build web services like this. In the last video, we looked at the what related to web services. We defined what is a web service. We looked at the fact that the three keys to a web service are it needs to support an application-to-application interaction, it should be platform independent, and it should allow communication over a network. In this video, we'll shift our attention to how. We'll answer some of the important how questions related to web services. Let's start with the first one. How does data exchange between applications take place? I have an application which is consuming a web service. How does the data exchange take place? We have an application A which is consuming a web service. Let's say the web service is related to a to-do application and it offers a list of to-dos back. The application A needs to send some input to the web service. It needs to say, I want to-dos related to Ranga. So it needs to send an input called Ranga, to the web service, and the web service needs to send an output back. Ranga has this list of to-dos. He wants to create a course on this topic. He wants to learn this topic more. Those list of to-dos have to be sent back to application A by the web service. So there is an input and there is an output. The input to a web service is called a request, and the output from a web service is called a response. So if application A needs some data from the web service or needs to perform some action on the web service, it creates a request. Application A will create a request saying, okay, I want details of to-dos of Ranga. Web service would look at the request, process it, and it would create a response with the list of to-dos that Ranga has, and it returns them back to application A. Request and response are the basic concepts behind web services. The important thing is web services should be platform independent. Our web service, we should be able to call it from a Java application, a .NET application, and a PHP application as well. How do we achieve that? Think about it. If the request format, let's say it's a Java specific format or a .NET specific format, will other applications in other platforms be able to send a request in that format? Nope. The important thing for the web service to be platform independent is that the request and the response also should be platform independent. They should be in formats which are supported by all different kinds of platforms. There are two popular formats for request and response. The first one is XML. XML stands for Extensible Markup Language. You can generate XML from a Java platform or a .NET platform or any other platform of your choice. You have a node, a closing node, another closing node, which is specifying the detail of the codes that we would want. I would want to get the details of course 1. I'm creating an XML request. So XML is one of the popular formats for request and response in web services. The other data exchange format is JSON. JSON stands for JavaScript Object Notation. It's the language JavaScript which is used typically on the front end. Now we are also using JavaScript in the back end like Node.js and things like that. But JavaScript for a long while was a language of the front end. And JSON is how JavaScript represents its objects. The great thing now is JSON is supported by a wide variety of platforms, not just front-end systems, but also back-end systems, Java, .NET, and all other platforms. So to make the web service platform independent, what we do is make the request and the response platform independent. The next question is, how does application A know the format of request and response? Application A needs to send a request to the web service, and once it gets the response, it needs to be able to process it and do whatever it wants to do with it. How does it know what requests to send, where to send it, and what is the format of the response? The solution to that is service definition. Every web service offers a service definition. The service definition would specify a request and response format. Okay, what is the format which is used for request and response? Is it JSON? Is it XML? Or is it any other format that's specified by your service definition? It specifies the structure of the request. How can a consumer create a request? What is the format of the request? Also defined is the response structure. What is the structure of the response which is returned by the service? The last thing which is part of service definition is how to call the service. What is the endpoint? Where is the service available? So the application A wants to make use of the web service. In this video, we looked at the important hows related to a web service. How does data exchange take place? Through request and response. How do we make web services platform independent? By creating platform independent requests and responses. By using data exchange formats like XML and JSON. How does an application know the format of a request and response? We do that by providing something called a service definition. In the next video, we'll look at some of the key terminology related to web services. Welcome back. In this step, we would want to create a simple In the last couple of videos, we were introduced to the what and the how of web services. In this video, let's revise some of the key terminology that is associated with web services. Request, response, message exchange format. We'll look at what is a service provider, what is a service consumer, what is a service definition, and what is transport. Let's start with request and response. Request is the input to a web service and response is the output from a web service. Message exchange format is the format of the request and the response. Are we using XML? Are we using JSON? What is the format of the request and response? That's basically the message exchange format. The next key terminology is service provider and service consumer. Application A wants to consume a service from the web service which is present in here. The web service here is called a service provider. Service provider is the one which hosts the web service. The service consumer is the one which is consuming the web service. Application A in this example is a consumer of the web service. In this example, the Java application, the .NET application, and the PHP application are the consumers of the web service. We looked at service provider, the guy who's providing the service. The service consumer is who is using the service. The next important terminology is service definition. The service definition is the contract between the service provider and the service consumer. The service definition defines what is the format of the request and response, XML or JSON. What is the structure of the request? What is the structure of the response? And where is the service available? That's the endpoint. Endpoint defines what URL the service is exposed at. How can the service consumer call the service which is exposed by the service provider? The other key terminology is transport. Transport defines how a service is called. Is the service exposed over internet? So I'll be given a URL and I'll call it. Or is the service exposed over a queue? Two popular formats are HTTP and MQ. HTTP is basically over the web. Just like you type a URL in the browser, in a similar way, application A would call the web service. The other format is MQ, is to use communication over a queue. The service requester would place a message in the queue. The service provider would be listening on the queue, and as soon as there's a request on the queue, it would take the request, do the processing of it, create the response and put it back in the queue, and the service requester would get the response from the queue. The transport which is used is MQ. It does not necessarily be WebSphere MQ, it can be any of the other MQs as well. But the fact is the communication happens over queue. This is called a web service which is exposed over the transport MQ. The last key terminology we looked at was transport. Transport indicates whether the service is exposed over a queue or whether it's exposed over the web. That's the internet. Idea behind this video is to provide a quick overview of all the key terminology which is associated with web services. Most of this is what we have discussed in the earlier videos. We wanted to make sure that there is no ambiguity in understanding of these key terminology, because we would be using this terminology during the next steps of this course. Until the next video, bye-bye. In the last video, we talked about SOAP web services, and in this video, you'd start with an important concept called REST. What is REST? What is REST all about? REST stands for Representational State Transfer. It is a term which is coined by Roy Fielding. If you remember, Roy Fielding is the guy who also developed HTTP protocol. The key thing about REST services is the fact that they would want to make best use of HTTP. Okay, what is HTTP? Let's take a quick overview. Let's go to Google. I'm typing www.google.in. I would want to search for what is a web service. The browser comes back with a response, and I can choose one of these links and click it, and then I can choose any of the links which are present in here as well. So this is how we typically browse the web, right? This is how we browse the internet. While we were browsing, there was a lot of things which were happening in the background. This is how a simple interaction happens between the browser and any of the servers of the websites you are visiting. For example, Google. What happens is when I enter a URL in the browser, a request is being sent to the website server. And the website server responds back with a response. The important thing that we would need to talk about is what is the format of this request and response. These request and response are in a format which is defined by HTTP, Hypertext Transfer Protocol. When I type in a URL in the browser, it sends a GET request to that server. The server responds back with a HTTP response containing the HTML. So I'm sending a GET request and the server is sending back a response, a HTTP response containing the HTML. The browser looks at that response, takes the HTML and displays it on the screen. Let's say there's a form I'm filling up with a list of details and I click the submit button. In those kind of scenarios, typically we are creating a post request. HTTP defines the headers which are present in the request and the body of the request. Also, along with the response, there are headers and also the body. In addition to the request header and the request body, HTTP also defines something called request methods. You can indicate what action you are doing by using the HTTP request methods. Get, I'm trying to get the details of something. Post, I'm trying to create something. Put, I'm trying to update something. A HTTP response, on the other hand, will also include a HTTP response status code. Was it successful? Was it page not found 404? And things like that. Roy Fielding said, why do we need to reinvent the wheel? Why don't we make use of HTTP to develop our web services as well? And that's where the concept of Restful Web Services comes in. Restful Web Services try to define services using the different concepts that are already present in HTTP. The most important abstraction in REST is something called a resource. A resource is anything that you'd want to expose to the outside world through your application. For example, when I talk about the to-do management application, the users are a resource. Who is using it? Ranga is a resource. What are the to-dos also can be a resource. A specific to-do is a resource. A list of to-dos is also a resource. When we are talking about developing RESTful services, we are always thinking about resources. What are the resources in my application? A to-do, a user, a list of to-dos. What we do is we would assign a URI to the resource. For example, the URI to the resource Ranga is /user/Ranga. The URI to all the to-dos that Ranga has is /user Ranga to-dos. The URI to the first resource that Ranga has is your user Ranga to-dos /1. So what we do is we assign a URI to each resource. REST does not worry about how you are representing your resource. Is it XML? Is it HTML? Is it JSON? That does not really matter. The most important thing is the fact that you define your resource and perform the actions on the resource using whatever facilities that are provided by HTTP. Just like we discussed earlier, if I want to create a resource, I would do a post to /users. If I want to delete something, do a delete to /user/1. Get /users. Get /users/1. The important thing about REST is the fact that you have to think in terms of resources. What are the different resources that are present in your application that you would want to expose to other applications? And the second thing is make use of HTTP. If you want to do any operations on the resource, you have to use the verbs which are already specified by HTTP. Get, put, post, patch, and things like that. In REST, we don't really have any restriction on the data exchange format. While JSON is very popular, REST does not worry whether you're using JSON, XML, or whatever format you would want to use. Important thing is transport is always HTTP. REST is completely built on top of HTTP. There is no standard service definition which is attached with REST. That can be a drawback in some scenarios because when a client wants to consume a service, it needs to understand the request format and response format. So a service definition will be really useful. WADL, it's called Web Application Definition Language. WADL is one of the formats in which you can specify your RESTful web services. It has not become very popular. Another option is Swagger. Swagger is gaining a lot of popularity, and we would use Swagger in this course for defining our RESTful services. REST focuses on your resources and how do you perform actions on them, making best use of HTTP. Welcome to this step where we would set up a project using Spring Initializer. We would want to build our RESTful web services. What we'll do is we'll use start.spring.io to initialize our Spring project. We would want to generate a Maven project because Maven is the build tool that we are going to use. Language is Java. And we would want to use a Spring Boot version greater than 2.0.0. So select anything which is greater than 2.00 snapshot. You should be fine. The other things we want to specify is the group ID. I would want to use the group ID com in 28 minutes REST web services, and I would put an artifact Restful Web Services. For any Maven project, we need to give a group ID and an artifact ID. You can kind of compare this like a class name and package. We would also want to add a few dependencies. The way you can select dependencies is by typing them in. So I would want to select web, that's this Spring Boot starter web dependency. We are going to build Restful Web Services, and if you remember the things from our starter projects, you'd remember that Spring Boot starter web is the starter for developing Restful Web Services. It is also the starter for developing web applications. Now, I would want to also add in DevTools. DevTools makes it easy for developing applications, so I'll add DevTools in, and I would want to use JPA at a later point in this course. JPA, and I would want to use H2 as the in-memory database. Let's add it in as well. Once you do that, you can click Generate Project. What Spring Initializer does is it would create a Maven project, put it in a zip, and that's what is downloaded to your downloads folder. What I recommend you to do is to unzip the zip file to some folder on your hard disk. The zip file is downloaded. You can take this, unzip the file to some folder on your local hard disk, and launch up Eclipse. Once Eclipse launches up, you can import the project by using File, Import, Existing Maven Projects, and you can browse through to the directory where you unzipped your zip file to. This is the root directory to which I unzipped my zip file to, and I can see a pom.xml coming up with Restful Web Services. You can also use browse to browse through to your folder. Once I click Finish button, what Maven does is it would actually download all the dependencies which are listed in the pom.xml. And it would also set up the entire project for us. So let's go ahead and click the Finish button. This might take a little while if this is the first time you are using this specific version of Spring Boot, because this downloads a lot of Maven dependencies. What is happening in the background is the complete setup of our Restful Web Services projects. Once the project is set up, you would see a folder structure like this. This is typical Maven project structure. Source main Java, source main resources, source test Java. Source main Java contains all our Java code. There's not a lot in here right now. We have source main resources with the properties file. So there's application.properties, which is the Spring Boot properties file. And we have the tests, which can be written down in source test Java. We also have a pom.xml, which contains the dependencies which we have chosen. The pom.xml contains the dependencies starter data JPA, starter web, DevTools, H2. and starter test. The first four dependencies are what we have chosen on the start.spring.io website. Web, DevTools, JPA, and H2. That's what we chose. And those were the dependencies which were in here. And by default, Spring Boot would add in, Spring Initializer would add in a dependency on Spring Boot starter test. This is the one to write your unit tests and integration tests. If you go and look at your Maven dependencies, you should see a lot of dependencies which are coming in because of the starters we are using. Now that we have an overview of the project that we are looking at, let's start up the Spring Boot application class. Right click, run as Java application. We have not really written any code as of now, but that's fine. We will write a lot of code in the next steps. For now, what we wanted to check is if the application is launching up fine. If the application launches up fine, then we are good to go. You can see that there is a lot of log being generated, and you would see by the end of the thing that the Tomcat server has started up. So you can see that Tomcat has started on ports 8080. There's a lot of magic which is happening in the background. We will uncover all that magic in the subsequent steps as we develop more and more RESTful web services. Until the next step, bye-bye. A simple controller, a REST controller, which would return some hard-coded text. This is like your hello world RESTful web service. I won't really call this a RESTful web service. Let's just call it a service which returns some text. I'm going to create a new class, Control N or Command N, type in class, and I would want to create a new class. I would want to call this Hello World Controller and click Finish. What I want to do in this Hello World Controller is I would want to create a method, and I would want this method to return Hello World. That's basically what we would want to do. Whenever we create a REST service, we would need to define two things, right? One is what method. So I would want to use get method, and I would want to use a URI. What URI do we want to use? I want to use the URI / hello world. So if somebody goes into their browser and sends a get request to / hello world, I would want to send him some text. That's basically all that I would want to do in this step. One of the first things that we would need to do is to tell Spring that this is a controller. So this is a controller in the sense that this would be handling HTTP requests. So we need to tell Spring that this is a controller, and next we would need to create a method. So the method would be, let's say, public. It's returning a string, hello world, so I'll call it string, and let's call it hello world. What should this method do? Simple, right? We would want to return this string back. So I would do that, return this string back. To this method, I would need to map a get request to the URI hello world. There are two things now we have to do. One is to call this a controller, so we need to say this is a controller, and then we would need to map a get URI of / hello world to this. How do we do that? Let's focus on the controller first. We would want to tell Spring MVC that this is going to handle REST requests. How do we do that? The way we would do that is by using something called REST controller. So at REST controller, now this becomes a controller which can handle REST requests. The next thing is to create a mapping for this method. I would want to map a get request to this URI. One of the ways of doing that is to create a request mapping. So I type in at request mapping. This is an annotation. I'll import the annotation. I pressed Ctrl+1 and imported it in. And here I can define what is the request method. Request method that we want to use is request method dot get. So the method we want to use is get, and the URI. How do we map the URI? That's by using the path. Path is equal to /hello world. That's it. It's as simple as this. Now let's start our Restful Web Services application. When I type in localhost 8080 /hello world, you'd see hello world displayed on the browser. What we have done until now is we put a very simple annotation at REST controller, and then we mapped get request to this URI to this method, and whatever text which is returned by this particular method, it's displayed on the browser. We can improve this further. Instead of using at request mapping, there's an annotation called get mapping. So I can say get mapping, import get mapping, and now I don't need to specify the method is equal to request method dot get. So I can say get mapping path is equal to hello world. Similar to this, there would be other mappings like post mapping, put mapping, and other mappings that we would use in the subsequent steps. I like the add get mapping annotation because it's quite short and it's very easy to read as well. So I'm mapping a get request to hello world. Isn't that a cool thing? I'll organize my inputs, Ctrl+Shift+O, and let's restart, and you'd see that the service would continue working. In this brief step, we created a simple hello world request. In the previous step, we returned a hard-coded string back. We mapped get request to this URI to this method which was returning a simple string. In this step, we would actually create an object for hello world bean and try to return that back and see what would happen. One of the things you need to understand is the fact that there is a lot of things that are happening in the background. We used Spring Boot to create the project. Through the Spring Boot starter projects, we are using frameworks like Spring MVC, and a lot of other things. So there is a lot of magic which is happening in the background. Before we get there, we would focus on getting another simple get request working. So I would copy this method. There would be a compilation error. Let's not worry about it right now. What I want to do is to create a get mapping to hello world, and this time I would want to create a bean and return it back. So instead of creating a simple string, I would want to create a bean and return it back. The URI I would want to map is hello world bean. We would continue mapping the get mapping request. However, instead of returning a string, we want to return a bean back. How do we do that? Let's quickly do that. So we want to do hello world bean, and I'll make the change in the method name. Now you would see that the entire thing compiles. But instead of creating hello world, what I would want to do is to create a hello world bean. One more thing I want to do is to make sure that this method is returning a hello world bean. So instead of string, we want to return a hello world bean. Actually, the hello world bean is not really there. So let's go ahead and create that first. How do I create it? Control 1 or Command 1 and create class hello world bean. Let's do that. Hello world bean. I'll take the defaults and click finish. And I would want to create next. If you'd see, there's a constructor which is present in here. So let's go ahead and do a control 1 and create constructor hello world. I'd want to create a hello world bean with a message. What I want to do is this dot message is equal to message. Now I would get another compilation error. Now I press Ctrl 1 and I'm going to create a message in here. So we have a private field called message. We have a hello bean accepting that in the constructor and setting it to itself. Let's create a setter quickly. So I'll say select setters. Okay. The easiest way to do that is right click, source, and you can go and select generate getters and setters. So I generated setter, and obviously I would also want to generate a toString. So let's generate a toString as well. Right click source, generate toString. I'll say okay. So we are creating a very simple bean, nothing complex in here. So we are just creating a simple bean, and now our hello world controller would compile fine. So what we have done until now is very simple, right? We have defined a simple hello world bean which accepts a message, and we are actually returning it back in the controller method. Let's start the application up. Let's go to URI hello world bean. You would see that there is an error. There was an unexpected error. No converter found for return value of type hello world bean. This is one of the important things that you need to understand. Actually, this is not really an easy error to debug, and that's the reason why I illustrated this first step. So this hello world bean does not have a getter. So if we don't create a getter, then the automatic conversion will not work. So let's go ahead and create the getter. So right click, source, generate getters and setters, and select the getter for that. And now you'd see that the getter is present in here. Let's quickly restart the application. And now if you launch the hello world bean, you'd see a JSON message back. You'd see that message hello world. You can see that this message is adhering to a JSON structure. We are calling this get URI, and the hello world bean is being returned with the value hello world. And if you look at the structure, it's actually reflecting the structure in here. So it's just returning message and hello world. The name of the field here is message. So that's exactly what is here. And the text which is being set to the message is being presented as its value, and this is coming back as a JSON string. In this step, we added in one more simple method. However, this is returning a bean back. Earlier we returned a simple string back. Now we are returning a bean back, and this bean is being automatically converted into JSON and returned back. The first two steps were really simple, right? We just created a couple of simple methods. In the next step, we'll understand what's happening in the background of these two steps. How is the request being handled? Who is handling the request? And also, how is the hello world bean content getting translated to a JSON? We'll look at all that in the next step. Welcome back. In the previous two steps, we created a couple of simple methods. In this step, we'll try and understand what's happening in the background. You'd see the mappings that we have created. So we created a mapping from hello world get. We also created a hello world bean get. But there are additional mappings also present in here. For example, /error. When we look at the log, there are a few important questions that would come up. What is dispatcher servlet? Actually, we have not done anything about dispatcher servlet. So who is configuring dispatcher servlet? What does dispatcher servlet do? How does the hello world bean object get converted to JSON? And who is configuring the error mapping? So there are a lot of questions that you would have based on whatever we have done in the previous two steps and whatever was in the log. In this step, we'll slowly look at all these questions. I would want to actually start running this application in something called Debug Mode. And the way we can do that is by going to application.properties and configuring logging.level. I would only configure the Spring framework. So org.spring framework is equal to, I would say, debug. So I'm setting the logging level for org.spring framework to debug, and let's restart. When you restart now, you'd see a lot more log than previously, because now we are at debug logging. Spring Boot is outputting a lot of stuff, and all that is being shown in the log right now. One of the important things that you would see in here is something called an auto configuration report. The auto configuration report consists of a lot of details. If you look at the auto configuration log, one of the important things is configuration of dispatcher servlet auto configuration. It says dispatcher servlet auto configuration matched because it found a class called dispatcher servlet on the class path. What is happening here is we added in a starter on Spring Boot starter web, and Spring Boot starter web has a dependency on Spring Web MVC framework. Therefore, we get the dispatcher servlet class in our class path. So Spring Boot auto configuration says I found dispatcher servlet on the class path. So let's go ahead and configure a dispatcher servlet. The other thing you'd see is also error MVC auto configuration. So it says, okay, these classes are found on the class path. So we would need to configure a error page. So it's configuring a basic error controller, a few error attributes, and also a default error view resolver. The error page which we looked at earlier was the white label error page. This was the thing which was generating that error page. In summary, all this configuration is getting fired because of something called Spring Boot auto configuration. Spring Boot looks at all the classes, all the jars which are available on the class path, and based on whatever is in the class path, it tries to auto configure different things like dispatcher servlet. In addition to whatever we have discussed earlier, the other things which are auto configured are things called HTTP message converters. So we had the bean automatically converted to JSON, right? So these HTTP message converters were responsible for doing that. So what is happening is something called Jackson to object mapper. So this actually does the conversion from JSON to beans and beans to JSON. Who is configuring dispatch servlet? Spring Boot auto configuration. How does the hello world bean get converted to JSON? It's also because of Spring Boot auto configuration, because the message converters and the Jackson beans are getting initialized. Who's configuring the error mapping? Again, Spring Boot auto configuration. It creates a default error page for us. Now, the last thing we would want to understand is the dispatcher servlet. If you look at the log, you'd see something like this: mapping servlet, dispatcher servlet to slash. What is happening here is dispatcher servlet is handling all the requests. So this is the root of the web application, right? So it's handling all the requests. Whenever you type a URL into the browser, whenever I type hello world bean into the browser, what would happen is the request would go to dispatcher servlet. Dispatcher servlet would be the one which would be handling that request first. This is following a pattern called front controller. Dispatcher servlet is the front controller for Spring Web MVC framework. So the request goes to dispatcher servlet. Dispatcher servlet knows all the different mappings which are present in the application. So it knows hello world get method is mapped to this method. Dispatcher servlet knows that hello world bean get request is mapped to this specific method. So once it gets the request, it determines which is the right controller to execute that request. So it looks at the URI and the request method. When we type a URL in the browser, we are sending a GET request. The dispatcher servlet says, okay, there's a GET request to hello world bean. Which is the right controller that would be able to execute it for me? It will find this specific method. It would see that hello world controller dot hello world bean is the right one to execute. So it would execute that. So it would make sure that this method is executed and this bean is returned back. Once the bean is returned back, then dispatcher servlet looks at how do I send the response back? I have a bean. Now how do I send the message back? We have at rest controller annotation in here. Part of the at rest controller annotation, if you look at it, is something called response body annotation. One of the important annotations which is present in REST controller is response body. What would happen when I put response body on a controller is the response from that would be mapped by a message converter into some other format. So here the message converter which is going to be used is Jackson. So dispatcher servlet would say, okay, do the Jackson conversion, do the conversion to JSON. It would actually convert hello world bean, whatever content is there in there, it converts it into JSON and sends the response back. The hello world bean request goes to dispatcher servlet. Dispatcher servlet finds the hello world controller, the specific method hello world bean. It calls it, gets the bean, invokes the conversion on it, converts it into JSON and returns the response back. Whether you're working with web applications or with Spring REST web services, dispatcher servlet plays a key role. We'll further discuss about dispatcher servlet when we talk about other things like security. In this step, we tried to take a quick look at the world behind this hello world controller. We looked at dispatcher servlet and how it controls the entire flow. Also, we looked at some of the things which are configured by default by Spring Boot auto configuration. If a few of these things are not really clear to you, not a problem at all. We will discuss about these a lot more in the subsequent steps. Until then, bye. Welcome back. When we talked about the resource mappings, we said some of the values would be passed in the path parameters. So here /user/id. id is a path parameter. In this step, what we'll do is we'll create another simple hello world bean request with a path parameter. What I'll do is I'll copy this, and what we want to do is we want to pass in a param. What we'll say is we'll create a URI hello world path variable / I want to accept the path variable in here. I would need to give a name to the variable, so I'll call it name. So what would happen here is when I get a request, let's say path variable / in 28 minutes, then in 28 minutes will be mapped to this variable name. So let's create a variable to take that. So that's called string name, right? So is that sufficient? Actually, it's not. I would need to add an annotation called at path variable, and now it's imported in. Now what would happen is when somebody types in a URI in 28 minutes, it would get mapped to the name in here. So this in 28 minutes would be what would be mapped into name. I'll change the name of the method. It doesn't really matter, but let's change it. Hello world path variable. Over here, I would want to use a format. So I'll say hello world %s. I'll use the name in here. So I'll say string.format, and this is the format to use, and I'll say use the arguments name. What would happen? This %s would be replaced with name, and this hello world bean would be returned back. So what we are creating here is very simple, right? What we want to do is to take this path variable And whatever value is coming back, we are creating a hello world bean with this string template and returning that back. It's a simple example to show the power of path variables. In all our social media application resource mappings, we will use path parameters extensively. So here we are mapping user ID. Here we are using post ID. In RESTful applications, we make extensive use of the path variables. These are also called path parameters. Now let's start the application, and I'll copy this hello world path variable in 28 minutes down here. So it's localhost 8080 hello world path variable in 28 minutes. And you are seeing now that it's coming back with a response. Hello world in 28 minutes. Whatever I'm passing in as the path variable is getting replaced in here. Let's change it again. Hello world Ranga. This is getting as hello world Ranga. So whatever value we are passing in is being picked up by the controller and it is being sent back in the response. Path variables are a critical part of creating REST resources. We will make extensive use of path variables in this specific course. In this step, we learned how to create a path variable and how to pick up the value from it and use it in a controller method. Until the next step, bye-bye. Welcome back. We now have